Hello, everyone. My name's Henry Hahn, as Quentin mentioned. I'm one of the technical product managers here at AWS. I'm going to take you through a overview of how we launch applications here at Amazon and AWS, and how you can start doing that as well. So we'll go ahead and get started. So we'll start with a quick overview. I'm actually going to start with a discussion about DevOps. Now, I know many of you probably heard about DevOps. Some of you may be practicing DevOps. Some of you may be interested in sort of transforming to a DevOps model. We'll talk about that in a fair bit of detail because that's important as we lead into what Amazon has done in terms of building applications, building services, and how the DevOps model applies. And then finally, we'll actually talk about the AWS developer tools that enable you to implement a DevOps culture and software development process in your own organization. And I'll do a few demos here as well so you can get a visceral feel for what we're actually talking about. So most of you, this is obvious. Software is moving faster than it ever has. And the pace at which software moves is strongly correlated to the pace at which your business is moving. If you're delivering software as a product, then updates to that software and changes to that software, improvements to that software need to happen on a regular basis for you to stay competitive. If you're delivering software, not maybe as a business, but in a role where you're supporting other businesses or you're supporting your organization, those are customers as well who are expecting the software to be updated in response to requirements and really kind of an ever-changing landscape of usage patterns. So the intent of the DevOps model that we'll talk about is really about enabling you, your organization, and your teams to move faster in delivering software updates, and new features. So DevOps. We'll talk a lot more here in a second about what DevOps means, but let me start with the high level in terms of how this relates to moving faster. It was 2015, Puppet Labs did a State of DevOps survey. And what they found was that high-performing IT organizations deployed 30 times faster, had 200 times shorter lead times, 60 times fewer failures, and 168 times faster recoveries when it came to their software development process. Now, we'll talk about these and what they mean, how that relates to Amazon here in a bit. But think about 30 times more frequent deployments. That's basically sort of a rough measure of how frequently value and features are being delivered into your product. 200 times shorter lead times, that means how much faster are you able to get that software delivered? And then failures. Failures, especially when you're running a services type of model that has uptime, failures are something that occur and you need to deal with, but the goal is to really reduce those and to as few as possible. And then, of course, if a failure does occur, you want to be able to recover very quickly. So that is the context here as we talk about the DevOps model and how that's used in Amazon. First, we should talk about DevOps. Most of the time when you're using a new term, you should start with a definition. I jumped ahead a little bit just to give you a preview of why we're talking about it. But what is DevOps? Well, the two pieces of that word are development and operations. What we mean by DevOps is the combined software practices of combining development and operations together into a single organization or function. And what that really comes down to is we kind of summarize this into three key elements. One is cultural philosophies. We at Amazon do things in a particular way, and the DevOps model has sort of some cultural philosophies that really make it possible. There are some specific practices that DevOps is sort of organized around in terms of how you're actually developing the software, the structure of your software, how you release that software, and then, of course, there are the tools, the things that actually enable those practices. So DevOps culture. Now, I'm going to spend the least amount of time on DevOps culture, but it turns out this is probably one of the more important elements. At Amazon, we are customer-focused. We think about problems and delivering value for customers first, and we work backwards from there. So that's kind of the culture that we have at Amazon is really about the customer and working backwards from there. And so this model is about supporting that. We found that we get the best results when you have the development and the operations together. And part of the reason for that is that the development, think of that as the writing of the code, the development of features, that is combined with the infrastructure where that software is run before it's delivered to a customer. So the customer's experience is actually the combination of the code and the infrastructure where that's running. If there's a problem with the infrastructure, the things that you would operate, if there are increased latencies, if the hardware is having a problem, then the customers aren't able to use those features. They aren't able to use the software. So combining development and operations drives this overall shared sense of responsibility and ownership that teams have of the experience that's delivered to customers. Rather than having one team solely focused on one component of the model, where it's two separate concerns, you have somebody that's looking across both of the pieces and ultimately able to own the end customer experience. Now, of course, that also means there's good communication amongst the team, there's good collaboration. We'll talk about that when it comes to tools, but there's also good visibility. We'll talk about that a little bit more in terms of process and tools as well, but by visibility, the simplest way to think about this is we monitor and understand how the application, the service is running and what the customer experience is. I mentioned one potential measurement, latency. How quickly can customers effectively get to your application and experience the application? If it's very slow, that's probably a negative. If you're trying to improve that, you obviously need metrics to understand that that's happening, and so you can ultimately improve it. All right, DevOps practices. So we talked about culture, and I'm just going to go ahead and jump right here into practices. We'll start with one of the first, and that is rather than having single large monolithic architectures or applications, we think about the architecture of DevOps applications, if that's a term, as microservices architecture. That means breaking down larger applications into individual components that are easier to manage, monitor, and update and be worked on by individual teams and team members. So moving from the monolithic application structure to a microservices architecture is one of the most important and fundamental aspects of DevOps. And of course, this is, especially when it comes to cloud applications, this is a much more natural fit too, because you've got a bunch of different services then running in the cloud that you stitch together. In an earlier slide, I talked about how high-function IT organizations are actually deploying faster. Well, in order to deploy faster, if you relied solely on manual processes, you probably wouldn't achieve the level of delivery that you want to deliver, including the ability to reduce failures and recover. So one of the aspects of DevOps practices is continuous integration, or there are different sort of forms of this: continuous integration, continuous delivery, and continuous deployment. The sort of meta point is that you want to make the process of deploying your code and updating your code as automated as possible. So we talked about microservices in terms of application structure. In terms of updating that application, we want to make sure that we can automate as much of that as possible. Now, in a pure development team environment, you might think about the code of the application, the dependencies that are included. But when we're talking about DevOps, we're talking about both the development and the operations. We need some way of managing the actual infrastructure itself. And I mentioned this before, the infrastructure is effectively part of the application. Because the code and the infrastructure go together, you want to manage the infrastructure with just as much care as you would with the code. And that includes the definition of your infrastructure, updates to the infrastructure, really any changes that you want to apply to the infrastructure. You would apply similar practices that you would see with the application code itself. So the third practice that we talk about is infrastructure as code. So that's being able to define the infrastructure where your application is running as code itself. Now, here at AWS, we have a service called CloudFormation that enables you to do that. There are different ways to support infrastructure as code. CloudFormation is not the only one, but as a practice, that is a strong element of DevOps. All right, and then the fourth practice, I alluded to this earlier on, was the visibility, the ability to monitor and understand what's happening in your application, to your infrastructure, what the customer experience is. So the first aspect is monitoring. Can you even see what's happening with these customers? What is their experience? Do you have visibility if there are failures so that you can quickly address them? So you want to, first of all, when you're delivering software in a DevOps model, you want to make sure that you have, really before you even launch the application, the ability to see how your application is working. So that is kind of a combination of monitoring, which here at Amazon, we use a lot of metrics. Those might be things like measuring the latency of application requests, that might be measuring error rates. There are a number of things that you can measure. Logs are also really important. Logging data contains a lot of important information for monitoring applications. If a problem does occur, you want to be able to address as quickly as possible to limit the overall impact. And one of the aspects of that is understanding, it is all in real time, both your application and your infrastructure, having the log data to drill in and troubleshoot so that you can remediate any problems as quickly as possible. And of course, you don't want to wait until those problems start being reported by customers. You want to have a handle on this before that happens. So when we actually deliver an application, this is very true at Amazon, I'm sure this is true at other companies, we have very exhaustive monitoring that is put in place and alerting that's put in place that notifies us should a problem occur. So those are the four practices of DevOps. We're going to jump into tools in just a second, but to summarize, the benefits of DevOps really are about delivering value to your customers faster, having better reliability in terms of the speed of your organization and the velocity of delivering to the marketplace. This is really what this is about. Now, in terms of Amazon's experience here, this is where I'm going to do a little bit of a quick history lesson. So Amazon did not just suddenly decide they were going that we were going to adopt a DevOps model. This has actually occurred over time, and we've learned a lot as we've gone. That learning has not stopped, actually. We continue to learn, we continue to figure out how we can improve, but that learning has also led to the products that we've delivered to you, the customers who can use these today. But let's talk about where we started. Between 2001 and 2009, Amazon was undergoing a change in how the applications and the organizational structure supported software delivery. So we moved from more monolithic architectures with more hierarchical organizations to one that we actually call these microservices, decoupled services, and an organizational model that we call the two-pizza team. Now, what we mean by two-pizza team is that the teams that are supporting an individual service, maybe an individual microservice, can be fed with two pizzas. And I'm sure the team size might vary, and the number of pieces of pizza that people might eat might vary quite a bit, but I think you get the idea. Our teams that support services are not huge. They are supporting an element of an overall product or service that may be rolled into a larger product or service, but they are an individual team that, in theory, could be fed by two pizzas. So we migrated from monolithic architectures and hierarchical organization to more of a decoupled service model with two pizza teams. So when we changed this model, we saw that things actually operated much better. Teams were able to deploy and to update faster, but we saw that there was still opportunity for improvement. In 2009, we actually ran a study to identify where there might be additional inefficiencies. This is actually a talk and study that you can find called Understanding Amazon's Software Development Process Through Data. I believe that's from 2009 by John Rauser. But we really wanted to understand what was it that could happen, or what could we change to make things go faster? I'll highlight really looking at data is a very fundamental aspect of the Amazon culture. We want to understand, based on the data, how we improve. So that got kicked off. So we started looking at this process, and you could roughly break it down to writing code. So application code would be built, written. That code would need to be built. We would deploy it to some sort of test environment to make sure that it actually operated the way we wanted it to, and then we'd ultimately deploy that to production. But what we found was that was really a set of 2 steps per stage. What there was when we'd write code, the code writing could be minutes, maybe hours, depending on what was happening. But what would happen was once the code was written, somebody would send an email or cut a ticket or basically request that somebody review that code. And that back and forth, when nothing was really happening in terms of actual work, could take days. And we saw the same thing across build. Somebody would actually run a build. It would only take a few minutes, but the process of requesting the build and getting the build results after emails were sent and tickets were cut would also take days. The same with deployment, the same to test, the same to prod. So what we saw is this process could end up taking weeks, and a large fraction of that time was just waiting. So what we ultimately identified was that we need better tools to support this process. We need to automate these. The things that humans really weren't doing, we knew we could automate. And that's where we ended up building our own tools. There weren't pieces of software that were just sitting on the shelf that we could go out and buy. And we knew that at Amazon, enough of the organizations benefit from these tools that we have teams now that build these tools, and we'll get to that and how that was released as new services. But the fundamental model doesn't change with these tools or the tools that we've built internally. So I'm now going to go from that story of Amazon and how we got there to what the process is that you can start using our tools today. I'll start out with saying we have used our own tools very successfully. In fact, in a year, we will actually deploy more than 50 million times. And what that actually works out to is about 1.5 deployments every second. So in the time that you've actually been in this talk listening, we've actually deployed thousands of times. So you can think about that for a little while. And the technology that we're doing that is available to you. We'll get into that in more detail, but the enablement for this was a DevOps culture, a DevOps model. This is working for thousands of service teams across Amazon, both Amazon, the retail business, and AWS, built on microservices. They're practicing continuous delivery, and they're not only, in many cases, they're not just a couple stages where you have test and production. You can have multiple stages. It can be quite a bit more complex, but fundamentally, it's all the same model that has enabled a scale like 50 million deployments a year. Okay, so getting to the question of how you start taking advantage of the way that Amazon launches applications. We're going to talk about the tools. So we have a set of Amazon Web Services that enable different aspects of this entire DevOps process. So I'll go through each one of these and talk about what they are and some of those benefits, and then we'll even talk about how those things are used. So ultimately, if you think about the overall software release process, it's writing source, building, testing, and then deploying to production. So we have a source service. We have a Git-based source service called AWS Code Commit. This is a highly available and highly scalable Git-based source control service that you can start using today. You can use that for yourself. You can use that for your teams. It's integrated with all the other goodness of AWS, including things like monitoring and CloudTrail and API access. About a year ago, we launched a new service called AWS Code Build, and that is a managed build service that really takes the pain out of managing infrastructure or hardware that you would need to run your own builds. Code Build scales up and down for you on demand. You pay only for the minutes when it's running. There's no hardware that's sitting around that you're paying for. Very easy to use, and again, highly available. easy to access either through our console or through the APIs. I'll talk about this a little bit more, but we have a number of third-party tooling integrations that you can use to add testing to your overall process. And then in terms of deployment, whether that's to production or to test or other environments, we have AWS Code Deploy. AWS Code Deploy lets you deploy code to our Amazon Elastic Compute Cloud service, EC2. You can also deploy code to on-premises servers or other providers' servers. There's an agent that supports that. We more recently actually launched the ability to do deployments to Lambda. And that basically means that you can define the strategy for how your Lambda functions are deployed. Now, I'm using an AWSism. If you're not familiar with Lambda, you can go look that up. AWS Lambda is the AWS serverless technology. So we've expanded our capabilities there. There were a number of announcements in the last week. We had AWS reInvent. We will also be providing support to deploy to ECS, both to ECS and the new technology, the new container technology, Fargate. That will be available in the next few weeks as well. Now, orchestrating this entire process, providing this continuous integration, continuous deployment delivery, is managed by a service called AWS Code Pipeline. And what Code Pipeline does is helps you automate the process between each of these steps. We talked before about all the waiting that potentially happens between each of these steps. Well, Code Pipeline takes that waiting out of the process for you. So at a high level, those are the pieces. If you're interested in digging into more of those, you can search for each of those individually. They can be used together. They can be used individually. They can be used with third-party integrations. Just as an example, Code Pipeline gives you those integrations to third-party tooling. You can use GitHub, for example, with Code Pipeline rather than Code Commit. So these are pieces that give you the entire solution or let you pick and choose what makes sense for you and your team. In April of this year, 2017, we launched a new service called AWS CodeStar. CodeStar is a product that makes it easy for you to start developing using a DevOps model on AWS in just a few minutes. So if you're using the individual services, you can stitch those together the way you want. We introduced CodeStar to make it easy to set up all of those pieces into an individual project in just a few minutes. The entire project, the entire CodeStar project includes everything you need. That includes the source, tools, build, configuration for deployment. It includes a sample application. It includes the infrastructure definition that you need for that application to be running so that you can manage this entire delivery process easily. We have a number of templates. I believe there are over 30 templates now that let you pick and choose the type of application that you want. It's based on languages like Node and Java, C#. It's based on the compute technology that you want, or even the application type, whether it's a microservice or a web application, for example. Last week, we also introduced AWS Cloud9. Now, Cloud9 is the latest tool that we've released to support the development model. Now, Cloud9 is a cloud-based IDE that lets you write, run, and debug your code. You only need a browser for this, so there's nothing that you need to install or set up. That really simplifies, again, this entire process from really writing code to all the way to delivery when you combine it with CodeStar. There are a number of really great features in Cloud9. I encourage you to take a look at that. Independent of whether or not you're starting a new project, just check out Cloud9's a lot of really cool features. One that I think is particularly impressive is you can build AWS Lambda or serverless applications within Cloud9 directly. And there's some very specific support there that lets you not only deploy that to the cloud, to Lambda, but you can actually run and debug locally within Cloud9. So you can try things out before they're deployed. All right, so I've now done a lot of talking. I'm going to probably continue talking, But what I'm going to be able to show you now is the products and features that I've just talked about. And I'll try to tie those back to the overall theme about how Amazon is launching software. So the easiest way for you to get started with a Amazon-like software development process is AWS CodeStar. So you can go to AWS CodeStar in the console. So if you go to, you can go to our pages, aws.amazon.com/CodeStar. There should be a Getting Started link, and that should point you to the console where you'll see a page that looks something like this. I'm going to try to use this little pointer here because it looks like you're not going to be able to actually see me clicking on things. So hopefully it becomes obvious. But I'm going to go ahead and click that Start a Project button. Now I'll go over here and let's choose, I can choose a project template amongst the approximately 30 that are here. I'm going to do that based on the language that I want to use. So I want to use Node.js. You can see that we have C# and HTML5, Java, Node.js, PHP, Python, Ruby. So you can pick a template based on the language that you prefer. So I preferred Node.js here. So I've selected and filtered down to the Node.js projects. I'm going to go ahead and select a web application running on AWS Lambda, and that's the first one here. And let's see, I'll go ahead and click that. All right, so I've now picked my application type based on the language and where I want it run. The great thing about CodeStar is all you have to do is provide this project name here, and you're basically off to the races. Now, I'm going to show you a few little things first. So I'm kind of running a demo that I ran last week at AWS reInvent, so that's why I'm going to call that AWS reInvent 2017. You can use AWS Code Commit to start this project. I mentioned that's our Git-based source repository. Or we know a lot of customers really like GitHub, so you can choose GitHub if you like. Go ahead and try to click on that. So you can choose to create an application using GitHub. You don't have to use the AWS source control. But for the purpose of the demo, I am going to use Code Commit. So I'll come back over here, and I'm going to go ahead and click Next. All right. So my application is basically ready to be launched. I'm going to go ahead and hit the Create Project button just down here. There we go. It's going to get started. And it's off. Now, while that project is being provisioned, we're actually setting up all those tools. We're setting up the infrastructure. We actually give you a few steps to make your job a little bit easier so you can pick the technology that you want for editing your code. Editing the code is really where you're going to start in terms of changing applications that you launch with CodeStar. And we give you a number of choices. There's the command line tools. So if you just want to work with your own tools, run on the command line, you can always set up with the command line. We provide integrations with Microsoft Visual Studio and Eclipse, so you can use those tools with your CodeStar projects as well. And of course, I just mentioned Cloud9. We more recently introduced Cloud9. That is, of course, one of the options that you can do there. What's great about that is, again, there's no local setup. Everything's in the cloud. And not only that, we have even closer integration because it is in the cloud to do things like automatic cloning of your repos onto those workspaces and automatic authentication. So you don't have to worry a lot about those configuration details. All right, let me just quickly show you setting up using just the CLI. So what I'm going to do here is scroll down. So what we have is basically in-console instructions for going ahead and cloning the code locally if you're using command line tools. So I'll go ahead and click that copy button, see if I can do that. All right, and I'm going to go ahead and switch over to a console. Now I'm going to go ahead and paste that command in. So that lets me clone the repository source code locally. Clones in there, I'm done. The source code is now locally, so I can begin editing and committing that. But if I wanted something that was simpler, we'll go ahead and go back. I'm going to go ahead and pick Cloud9. So let me show you what that looks like. Now, Cloud9, as I mentioned, is a cloud-based IDE. It runs everything in your browser, so there's no software to install locally, and it actually works against a running server. So you get full terminal support. You get all the resources at your fingertips that you'd get from a virtual server. So I'm going to go ahead and use EC2. We make this really easy for you to set up. I'm going to pick the T2 Micro. It's one of the smaller server sizes. It's also eligible for the free usage tier if you're eligible for that in your AWS account. So I'm going to go ahead and pick that. I'll click next. Oops. And basically what's happening now is my project is being provisioned. Turns out while I was waiting, the rest of my project was provisioned, but my IDE is now in the process. There we go. So now the IDE is now available and I have my project. Now, I mentioned to you that this not only includes the tools and the infrastructure, it also includes a sample application to really get you started. So let me go ahead and click. We have this application endpoints tile in the CodeStar dashboard. We'll go ahead and click on that. And there you go. This is a running application. You can actually go up to that. It's an API gateway endpoint. But this was the sample application that I got out of this. So if you've launched a CodeStar project, you'd see exactly the same thing. I'm going to quickly go over the CodeStar project dashboard and kind of show you some of the things in there that support the DevOps style model. Some of these are elements that I mentioned before. Let's see, we'll go back to the application. I'll jump back over the dashboard. So when you launch a new project, you'll see things like this welcome tile. You can get rid of that if you want, but we have a number of things. Quick access to your application, quick access to your new Cloud9 environment, a team wiki tile here, which lets you add important or useful links that your team can reuse. Maybe those are playbooks, links to other resources, and it's really there for you to be able to customize. Scroll down here. There's not a lot of application activity yet, but we have a little monitoring tile that shows you application activity for Lambda applications. That shows you anytime that function's invoked. I've only run the application once. Excuse me. So we only see one invocation. We also show errors in the event that errors are occurring. I don't have any errors. And then let me actually use the arrow here again. So this is the application activity. We also have a commit history tile. So that actually shows you all the commits that have occurred in this project. We'll come back to that in a second. But this tile over here, continuous deployment, this is a tile that really summarizes the process of deploying your code from source to build to your production environment. In this particular case, we just have a single stage that we're deploying to. So we're actually going to show how that works in a little bit more detail. But the basic idea is I can see my entire process, which has been pre-configured for you as a part of that CodeStar, and making it very easy to deploy and take all the right steps needed to automate. So let me go ahead and show you what that looks like when we're updating the application. So we're looking at the dashboard here. We can see that application again. And what we could do, you saw me set this up before. I set up my code locally. And what I can go ahead and do is I could start editing that code here. So I see some files where I cloned it. I have a buildspec.yaml, index.js. I have a publics folder, a readme, and a template.yaml. I'm going to show you index.js. So what if we edited that? Okay, my index.js file is actually my Lambda function as a part of my project. So for those of you familiar with Lambda, this is our serverless technology. And what this is I can deploy this and have this code execute. Now, it's a very simple application that's shown here. Basically, I'm just loading a local index.html file. So we saw that public folder there, and we just render that. So that's a very simple hello world application. Now, I could go through this and edit this myself here, but if I wanted a little bit more support in terms of editing, something that's a little bit fancier, I can jump back here to that Cloud9 IDE that I created. So I jumped in. Actually, let me back up here. You can click on this IDE link on the side to get to that environment. You can scroll up in the dashboard. We had an IDE tile, but I'll go ahead and click on this one on the side here. There we go. And this actually shows me a list of all the Cloud9 IDEs that I have as a part of my project. There are there are environments that I've launched, that's the one that we're looking at here, where you could have environments that you're sharing with other team members for collaborative editing. We're going to just talk about this individual IDE here. So I'm going to go ahead and click on OpenIDE. And what that's going to do is that's going to launch me into my Cloud9 IDE tab. And there we go. Now in my Cloud9 IDE, we've got a welcome here because I've just set up this project. Now before, I had to clone my code locally, and I could edit it locally, I could commit locally. That requires, there was some authentication that I had to set up, and was actually running those commands. What Cloud9 actually does, and it's maybe a little bit hard to see here because the font is a little bit small, is it's actually been cloned locally. So you can see in this tree view structure on the left-hand side that my same code is now on this environment that I'm using. So we're going to go ahead and click on that up here. There's my source. I can see that I actually have that index.js. So we'll click on that. And there we go. It's the same code that we saw before, but it's already been cloned onto this workspace. If you actually look at the command line, you can see that it was cloned automatically down here. So what I can go ahead and do is I can start editing that code directly here. I'm actually going to just comment out loading that file. And I'll go ahead and paste in my own here. And I'm just going to paste in a string contents that say hello world. So super simple. Now, if you are using Cloud9 and you are using AWS Lambda, there are a bunch of really cool features that we've added for those Lambda use cases. I'm not going to show those today. We don't have time. But if you look at the tabs over on the left, the right, let's see if I can point to this correctly. We actually have AWS resources. If you open that up, it'll actually have already identified the Lambda function that's part of your project and give you the ability to run that locally. So you can try things out and see the functionality and actually preview the application before deploying it. Very, very cool capability of Cloud9. Actually, when I was putting together demos for reInvent last week, a similar talk that I gave, I think it took me about 10 minutes to basically build my own custom microservice using a combination of Cloud9 and CodeStar. So a lot of fun stuff that can happen there. Now, I'm going to go ahead and I've saved this out. I'm going to go ahead and commit this just in the interest of time. That I'm actually going to push directly. There are different ways to do this, but in the interest of time, I'm just going to show this quickly. So let me go ahead and I actually need to configure my username and email. I'll go ahead and do that here real quickly. Rerunning these commands. All right, so the first thing I'm going to do is I'm going to add the changes. Actually, let me actually go to the folder and go ahead and do a git add dot. Added the changes. I'm going to go ahead and commit. I've got a small message there. So it's just pushing changes for the demo. That will be something that we'll look at in a second as well. And then I'm going to go ahead and commit that. Quick commit, small change. Now, what's actually happening? So remember we were talking about launching applications the Amazon way and how important the automation is. We've actually included automation in this project for you. So let me, there we go. I'm going to go ahead and go back to, I clicked on this tab. This is our CodeStar tab. I can actually, I'll show you. There was on the Cloud9 tab, and I'm going to click over here. Now I'll go ahead and actually go back out to the dashboard, and I'm going to scroll down here. Scroll down. What you can see is I've actually got this tile that looks different. What's happened is that when I committed that source, the code pipeline that's orchestrating this entire process identified that source has changed. And what that's going to start doing is pushing that code to the code build service to start packaging my changes up. In this particular case, this takes a little bit longer than I'm showing here, but in the interest of time, I'm going to fast forward it for you a little bit. It moves along to the build process. build will then move on to the deployment process if everything's successful. And then once that's deployed, we'll have actually completed that. So I didn't actually have to go do a bunch of manual steps. This was deployed for me. And now I can go back up here to my application link and click on that. And there we go. There's Hello World. Now let me, actually here, I didn't mean to go there. Let me actually go back over. One of the things that I'll highlight is you'll see that my commit showed up here too. So Cloud9 integrated with CodeStar, super simple, super easy, really a lot of fun. And we'll go ahead and go back out here. Okay, so I'm gonna quickly try to wrap up so we can get to some of these questions. So just real quickly, overview of what we just talked about. You can use all of the code services to build your own applications in the same way that we do at Amazon, from simple deployments to much more multiple stage deployments with different steps. There are a few updates that we actually made to these services that you may have heard about. Some of you may have not. Maybe you're, for the first time you're hearing about these, but I'll highlight them quickly. We launched that integration with GitHub that I mentioned. So when you integrate with GitHub, you get to see the source on your CodeStar dashboard. So you actually see those commits. We also show you your issues and your pull requests directly in the CodeStar dashboard, so you can quickly access that information. AWS Code Commit, we recently introduced pull requests. I was actually showing direct commit there, but you can create pull requests for somebody to review and to pull in to the source code. Code Build, we launched a couple things over the last few weeks. We actually added direct support for pull request builds for GitHub, so you can actually have the pull requests automatically built from GitHub pull requests. And we also added support for Amazon VPC resources. Quickly, last couple things on deployment. We added support for deployment for Lambda. So you can check that out. And then if you're interested or you're looking at this afterwards, there are a number of sessions that we presented at our annual conference, AWS reInvent. That was just last week. You can take a look for any of these talks here that give you even more detail. They kind of range from, looks like today's was a 200 level talk. There's a 200 level talk. Life of a code change to a tier 1 service is actually very entertaining. The presenter on that does a really great job of telling the story around it in a fun way, but there are also a lot of details that you can jump into. And of course, if you want to learn more about DevOps, check out our AWS DevOps workshop, which really gives you a detailed walkthrough of setting up all the pieces if you don't want to go through CodeStar, if you want to actually use the individual pieces. If you're using GitHub Enterprise or other Git technologies, we have a blog about that. And of course, all the services that I talked about today, you can visit the details page. All of those are aws.amazon.com/whatever the product names. Actually, it looks like I left Cloud9 off there. Obviously, go check out Cloud9 too. So thank you very much. I'm going to jump to some questions that my moderators